Okay. Hello, Mr. Ryan, are you right? Yeah?
It doesn't look like you're getting popular because you only have 3,000 subscribers right now.
Okay. So we are given an array of positive integers, yeah, and we're given a k. We're given an array of positive integers for simplicity, and we're given a k. K is bigger or equal than 0, okay? We want to find out the list of number of unique numbers, list of number of integers by removing k numbers from it, okay? So let's take this example, 554. If I ask you to remove k number, we should remove one number. If I ask you to remove one number, so we want to find out the least number. So the least number of the unique integers after removing k numbers. So can you tell me, should I remove 5 or remove 4? After removing k integers, we want to achieve the least number of unique integers, okay? So which number should I remove? The first one. If we want to remove one number from 554. Come on, how many choices?
There's 3. 2.
Two choice. Remove 4 or 5, right? The removing is 5 or 5 is 5. It doesn't matter, it's the same. So let's say if we remove this 5, what's left?
5 and 4.
5 and 4. So there are 2 unique integers. But if I remove this 4, how many numbers remaining? There's just 5, okay? So that's what I want. I want to remove this 4, so the remaining is only 1 integer. Okay, second example. We want to remove 3 numbers. So which 3 numbers we want to remove?
And get it to 2. 2 unique numbers. I think 4 and 2. 4 and 2.
4, yeah, we get rid of 4.
And 2.
And 2, yeah, and then, it doesn't matter, right? Because these are duplicate. Yes, and we can remove the 3 or 1, it doesn't matter. The remaining is 2 unique integers, okay? Yeah, makes sense? So what's your solution? What's your strategy of removing this? So, okay.
I just check through the list. I just check through the array.
Yeah, so
and find all the ones that don't have any duplicates. Basically, you just because if there's more than one, if I'm talking first.
Okay, that's fine. Yeah, one at a time. Okay, please, Ryan.
And if basically k is 3, but there's no point of removing 3 because it doesn't matter. There's still going to be another 3 anyway.
Yeah, but if I increase the k, then eventually the k 3 will be removed, right?
Yeah.
Yeah. Okay. If like k like a million or everything is removed, right?
If k is a million, that's greater than the whole.
That's
So
right.
it's so it's impossible.
Okay, so let's say, what's your strategy? Why removing 4 and 2 first instead of 3 and 1? What's your strategy?
I just went through the array.
Yeah, you literally just said it.
Went through the array and finding out which number. So for example,
just find like the numbers which have like the least population, so you can make it like extinct.
well done. The elements which less population, right? So least frequency, right? This is what I want. So we can count. We can find out the numbers which appears less, and we want to keep priority of removing those elements with less priority, right? Yes, because if we we kind of like remove this quickly. Okay, so if we remove the elements which appear less, then we can make it what's the word? Extinct, right? Yeah. That's the strategy. Okay, so in order to find out the numbers and then their frequency, we can use which data structure? With data structure to count the counter. Yes,
Yeah,
which is also the hash map.
A counter is a counter, get it?
Yeah, well done. Okay, so very simple. Define f array and k. Okay, obviously this k is bigger than or equal than 0. So we use the counter. So let's say if not array, we are given an empty array. Let's just return 0, right? Well, this is a special case. Okay, so c equals counter. We use the counter array. So basically, this c counter array. So these counter will return a hash map, which is a dictionary. The keys will be the unique numbers. The values will be the number of times they appear, right, Ryan? Yeah. Let's
Yeah.
Let's take a look at this. If we count an array, the first example, then you will return a dictionary, which is something like that. 5 appears 2 times, right? This is the key, this is the value. 4 appears 1 time, okay? The second example, 1 appear 2 times, 2 appear 1 time, 3 appear 3 times, 4 appear 1 time, okay? So this is the keys. This is the values, which is the number of times that appear. We can use this counter, which is a very handy utility to count, to iterate over the elements in the array, and then to count how many times each element appears. Okay. Obviously, we can do this.
You say everything's obviously. You
Okay.
find that everything's easy.
Yeah. Okay. Alternatively, we can iterate and then to update the frequency, but this is already available to use. Okay. So now with this C, so now we need to find out the least common, right? We want to find out the least common. For example, we want to remove this first. We want to remove this first, right?
I'm not saying does enumerate work. I'm asking is that enumerate?
No, this is not. This is the keys. This is the values. Okay.
What's
This is
that called?
dictionary, HMAP, dictionary, key value pairs. Key value pair. Okay, right? Okay, so we want to find out the least common, right? Least common one, right? If this is C, right? So we can access this is C dot values. Then these will be array of the values, right? But another way is we can use the counter dot most common. So when we say C dot most common, then it will return an array of a tuple, which is the KV, and then it will be sorted by the most common one. So for example, given this case, then if C dot most common, you return like that. 3 appear 3 times. And then what's next? 1 appear 2 times. And then it doesn't matter which one it could be 2 appear 1 time and 4 appear 1 time, okay? The order of these, I don't know. I'm not quite sure, but the most important thing is the second value in a tuple, which is the frequency. This is sorted by, decreasing order, most common, right? But if we reverse this one, then it will be least common, am I right? This is most common, okay? Most common. And then if we reverse these, there will be least common, am I right? And then we want to pick the numbers which appear less. Well, okay? So at the beginning, we have answer, which is the length of C, right? This is the number of unique elements. And then if we go through the element V in C dot most common, however, we want to reverse it. How do we reverse the list? Yes, column minus 1. This is the least comprehension, okay? Star, stop, step. Okay, minus 1 means the reverse. Then we need to check if we have enough elements, if K is bigger or equal than V, then K should be minus equal V. Then we're removing the V element. But in the meantime, the number of unique elements should be minus equal 1, right? And if we don't have enough elements to remove, if K is smaller than the number of the elements for that integer, then we just simply break, right? Because we have remaining integer for that. For example, like if there are two ones, okay? If there are 2 ones and we want to remove 1 integer, so what happened? We can't totally remove this 1, right? So we just leave it. So then we need to break, and then return answer. Okay? Does it make sense here? Yeah. This most common, right? And we reverse it, it will become least common. Unfortunately, the counter does not provide the least common, so we have to, use the most common and work around to reverse it. It will become least common. And then this V will be here, right? In sorted order. In the sorted order, we pick the number which appears less. Okay? So we want to remove it. Then we check if we have enough K number. If we want to remove K numbers, if we can remove this entire number, right? Because if you look, there are 3 threes. Okay? If we want to remove four numbers and then 4 is bigger than 3, it means that we can totally get rid of the 3, right? Then we can K minus equal V. That's the remaining. We update the remaining numbers to remove. And then answer -1 because we want to return the number of unique integer. It means that -1. What does it mean? It means that we have totally removed 1. We have make one number extinct. Okay? Extinct, that's the word. Okay? Otherwise, we don't have enough numbers. For example, like if we have remaining 5 numbers for number 1, okay? And then we want to remove 3 numbers, right? So can we totally remove this one? No, yeah. Even we remove 3 ones, then it will be 2 left, and we can't still get rid of this totally one. Then we break and return the answer. Okay. Time complexity.
When?
Yes. This is going once, O(n), and then this is going another n. Okay. So O to n, we drop the constant. The space complexity, O.
N.
O(n), yeah. We're using a dictionary counter. Okay. That's it for today. Bye bye. Bye.